Alright, hello everybody. Let's talk a little bit more about the actual upgrade package and what does it really what is it trying to fix and what things it's trying to implement. Hopefully you already covered all of the prior videos so you understand the overall goals and ideas just to simplify all of the communication related tasks. So if you're looking at the folder that you're downloading, the upgrade package inside of the firmware, you'll see all of the files and folders and subfolders that contain those that have modified or added some of the functionality. Pretty much all of the functionality. So first of all, if you go to the source directory, we already talked about how in modules we're adding this Simulink control module that pretty much does everything in terms of talking with the Simulink and providing the correct set of data, as well as forwarding that back to the PX4 and making sure that that's appropriately interpreted. So part of it is, again, we also covered the logging updates. Pretty much just enabling logging for all of the new topics, nothing special there. So a big part of it was also Mavlink communication, as well as modifying the commander. So let's start with the commander. Commander is it's the PX4 module responsible for interpreting all of the commands that are issued to the autopilot. And it's a pretty big module. If you go into it, if we go to source again, modules, you'll see it's basically the stitching glue between everything in PX4 and all of the possible commands and wrappers around the other modules that allow in this seamless interaction from the ground, just from QGC or any other third-party app. So one thing that I had to modify is if we go into the commander, well, it also is responsible for all of the pre-flight checks as well as arming, disarming of the PX4. So by default, if you use the Simulink UAV Toolbox for control system design, it's going to override the control system, right? And then it's up to you to either use the system arm flag, like the PX4 system arming disarming flag for arming disarming your vehicle, or you can ignore that altogether and run your control system sort of completely ignoring the PX4, as well as not letting PX4 know that we have armed or disarmed. So that is not something that I wanted to, and I obviously went in and modified the commander files. And basically all we're looking for, if we go to the commander main file, you're going to find all of the top level commands somewhere at the bottom. Port estimation check, battery stat. So you see all of these pre-flight checks, right? Data link check, all of these are here. You can keep them as is or modify to your own liking. You see how the control modes are being updated, all of the other functions, but what we're looking for is actually arming related functionality. Yeah, so there is, okay. Let's just search for that. Yeah, so update control mode, armed, yeah, see that? And I'm just going to get all of the references in this file just to simplify our work. So this is basically how you would also search for information within the PX4 if you were to continue development or just change some functionality, or you just want to learn about how everything is functioning, I would just recommend not even using the what is it, the PX4 documentation, but actually just reading the code. It's probably the most intuitive thing that you can possibly do in terms of, like, you see the code, you understand how it works, you don't need somebody else to interpret that for you. You see how all of this arming is being propagated, and there is a lot, like this entire file is all yes, here we go, that's what I was looking for. So I added a couple of parameters just for enabling different logic for arming and disarming, as well as allow these overrides. So you probably have a different line number for all of this because I changed the file, but the basic part of this was to go into this function and add the ability to disable disable the arming, disarming from within the commander, because sometimes there are cases when we want to override that from the control system or basically the sim control mod, as well as we want to use maybe any other functionality. So this is what I've done here. So you can see that there are parameters there, input source, like it's basically governing where the arming, disarming coming from. And then you can see also all of the actual disarm and arm commands. So they're all here. I think some of these have been modified. Again, you can cross-reference with the stock PX4. It's been a very long time since I've modified it. This is where you would look for any kind of change, because I mean this is basically it. Like, you have the disarm command and how it is being interpreted, what kind of method it's calling or function it's calling, and then you can look into additional modifications or parameters that were made in this function. If we go, but that's pretty much the main upgrade on the commander side, and this is more of a where to look for exact functionality of the arming, disarming logic, because that was a big part of making sure that everything is talking with the Simulink correctly. The other one was enabling all of the communication, like all of the modifying and adding all of the new Mavlink interpreters. Essentially, I'm not really adding any new Mavlink functionality. I've been using the existing one. So if you go to the Mavlink module, again, it's a pretty big one, but basically what you can pay attention to is the main file of the Mavlink module. So I think it's literally called Mavlink. That's right. Yeah, so just for example, let's just go back to the start of this function so you know what's the name of it. Yeah, so there are, for example, some default Mavlink streams, and this is something I mentioned previously. By default, there is what's called Mavlink mode normal, and these are all the topics as well as their streaming rates that are being sent. You can modify those. I decided to keep everything as is and simply add new mode, communication modes, because I think that's more convenient and less error prone. I added, for example, this Simulink communication mode that essentially uses everything above for a normal communication mode somewhere down here. Literally a copy of it. I just decreased some of the rates that the data is streamed at, because we don't need we needed to decrease the amount of throughput we have to use, because we added very demanding topics that we just want to prioritize as much as possible. So as you see, again, there are multiple parameters over here, like the Mavlink stream. Well, this is for a different module that you probably will not be using, but yes, so the other module, so there is this SM Mavlink stream parameter, so Simulink Mavlink stream enabler, that is governing, again, what type of messages do we want to send back. And as you recall, by default, it doesn't really do anything at all. Like, it doesn't send any of these Simulink packets. It makes those optional. The other three options are basically sending Simulink outbound, or Simulink inbound, or both Simulink inbound and Simulink outbound. And again, the main function for that was to configure local stream, and this is again the standard function of the PX4. So this is just how to add new messages or new topics to be sent back. And of course, this is just top level overview. You need to actually add what these messages are. So if you were to go to configure stream local, you would need to go to Mavlink stream. No, hold on. Yeah, receiver. I mean, these are fairly intuitive names, so you can pretty much follow the naming without really remembering anything. It's fairly simple. So this Mavlink receiver obviously handles the reception of all the data, the commands and all of that. So which what I'm looking for is to show you yes, if we go to actually messages, yeah, that's what I was looking for. So this is where a lot of pretty much where the Mavlink messages are defined. So that's probably a better place to start. So at the very top, I mean, you see just a whole bunch of methods being called for declaring different, what is it? Well, this is custom mode, never mind. Different Mavlink streaming messages that it can process. What I did, I was actually adding a whole bunch of existing messages, but creating new instances of those for UAVCAN, and then there's going to be, yeah, all of the debug float arrays. As you see, this for Mavlink, it's still just debug float array. I simply created different interpretation files for those. And you can take a look at the details over there, but it knows how to interpret those. It knows how does the Mavlink stream look like and how to interpret that. So there is no problem, again, adding those items. And I mean, if we go into this, just real quick, Mavlink messages, create stream, nope. We want to go here. Yeah, here we go. So this is a template class for all of the Mavlink debug float arrays. They're called Mavlink streams, and this is where you can check. I mean, I just defined a whole bunch of different types. This is how I've done it. There are multiple ways to do it, and then all of the decoding and interpretation is basically buried down in here, which there's not real decoding except for just, again, interpreting it as a different debug array message and publishing it as a separate UORB topic. So we sort of accept debug arrays of all kinds. They're all the same. We check the ID of the debug array, and then we publish it to a respective UORB topic. Or if it's just a debug array that we don't know anything about, we just publish it as a debug array. So, I mean, if something is new and hasn't been implemented, it would still be supported just like it used to be. But yeah, I mean, this is pretty much all you need to know for, or where to start looking for any possible changes you may want to introduce in the Mavlink communication pipeline. Let's see, what else? Talked about all of these. Oh, right. So, drivers. Talked about UAVCAN in a separate video. Distance sensors. So this is something we needed because we wanted to use lightware laser to 200 meter laser I think with the letter D. Let me check. Lightware lidar. I'm sure they're still sold, but basically we are using Lightware 30D, which is 200 meter range lidar. This is the one we are using, but it was not supported in the PX4 firmware, so I had to add an extra configuration setting for that. So if you go into your drivers, and by the way, I'm just using VS Code as for all of the code browsing. It's the same. Like, there is no difference between this folder over here and what I'm doing in the VS Code. It's just this is already an installed firmware, and VS Code provides nicer integration with everything. I mean, you probably already used that, so rangefinder, distance sensor, yeah, that's what it is. And then Lightware laser. So I added I2C support, although their I2C driver is just, I mean, on the rangefinder itself, not in PX4. That seemed to be a little unreliable. So I resorted to basically using this serial version. So if you go to the it already existed, it just didn't have the configuration for the correct configuration for this specific model of the Lightware laser. So I mean, if you used any of those lasers, you know that there is this sense enable SF0X parameter for all of the Lightware lasers that use serial or UART for communication. And then there are a whole bunch of settings for that. I mean, you can browse these in QGround Control and you'll see they are all labeled according to these. And basically all I've done is just we needed an extra configuration for the 30D to get all of the proper range settings, and so the data is interpreted, the analog data is correctly interpreted. Well, you may run into problems with just Python libraries being updated and no longer, I mean, basically being deprecated. So I copied this file because of what I used to run into every time I tried to use the stock Python library. Well, I don't remember the exact line in here. Match case wraparound. Let's do this. ABC. Well, if it ever throws an error, just let me know. But basically, this file should fix all of that. I just checked it recently with a freshly cloned PX4. That's no longer a problem, so you shouldn't have any problems with that. All of the CAN related parameters were actually added inside of the library folder where the PWM lives, just because that's where all of the actuator related parameters live. And you can check those out and modify as you want to, but I think I had a separate video explaining all of these in detail. That's actually it.